Hi, my name is Adeel Arif, and I am a member of Group 4, in which me, Adeel Arif, Bilal, Sajjad, and Nawaf Alshammari are the members. And we had to design a server room project in which we are using 7 segment displays to show the inside room temperature. The LM35 will be used to measure the temperature. The variable register is used to demonstrate the change in the line voltages, and virtual terminal is simulating the use of Bluetooth device that will be communicating through user and the embedded system to enter the passcode, which will allow the user to enter inside the room. So let me explain a few things before I start. The reference voltages to increase the resolution or to increase the resolution of the circuit are used, which will certainly improve which will actually calibrate the sensor so we can have a better results at the output, so we can observe them on the 7 segment display units. Because we are providing a 1 volt of reference voltages, so we cannot increase the level of a line voltages more than the reference voltages, because otherwise it will potentially damage the microcontroller. So this section is used to limitize the line voltages, or the limit of the line voltages will be within the 1 volts. So now the 10 bits of data will represent the maximum analog signal of a 1 volt. So there are 3 LEDs used: yellow LED to represent the temperature, red LED to represent the line voltages, and the green LED will represent the door, the opening door. The rest of the devices are connected to design the PCB, because these 3 cells are designed to are used to design the PCB, which I have already provided the separate video. So let's start this temperature. So we can see initially it will take 25 seconds to represent any temperature on the 7 segment displays, because it will take 25 seconds to represent the temperature, because in those 25 seconds it is taking 5 individual readings with the interval of 5 seconds. So the average will be represented on the output. So the first will be 25 seconds, and if the temperature is more than the 20 degrees, the signal will be generated, which will potentially activate air conditioning system to cool down the server room, so we won't have any problems in the data transformation. So we can see the first time when you on, it takes 25 seconds and the temperature will be appearing here. Once the temperature is more than 20 degrees, the LED will be on, because it will potentially cool down the server room. And imagine it's on, the server, the air conditioning system is on, and now the temperature is below 20 degrees. So the temperature, so now the temperature is below 20 degrees, and we can see now the temperature is below 20 degrees. It will take the average, and we can see it's now 19 degrees and the LED is off. So let's see, if we increase the temperature again, is 23. It will take some time, take the average, recent 5, and then it will show the change in the output, which will potentially turn on this LED. So that timer just only represents the first 25 seconds, which I use to show that the code is working according to the requirement, which will take me 25 seconds to take the first reading. And it will show. So we can see now it's 23 degrees, and so we can see the resolution, how accurate they are. So 23 degrees and 23.1, which is very, very accurate. So still having some error inside, so but overall it's very accurate, and the temperature LED is on. So now coming to the line voltages, the line voltages will be taken from here. That is the voltages that we will account for the line voltages. Once these voltages are below 0.5 volts, the LED will be turning on, which will representing an activation signal for an external power source to turn on, and to provide the external power source to turn on the system in case any disaster situation happen. So now imagine I'm increasing these voltages, I'm increasing these voltages, and once the voltages are literally 0.5, you can see now it's above 0.5 and it's off, and as it goes literally just below 0.5, it turns on. So we can see my code is working very accurate, and the maximum voltages that we can obtain from here are 1 volt. It will not go more than 1 volt because the voltage divider scheme I have used here. So we can see here 5 volts, but the system will not go more than 1 volt, otherwise it will potentially get damaged when you are building the hardware. So let's coming to the passcode section. So this virtual terminal is demonstrating the use of a Bluetooth device that is used as a we will be using a laptop or the smartphone devices that will demonstrate that that the user is communicating with embedded system through Bluetooth device. So if I turn on virtual terminal, so it, because at first when you enter the burn the code, it will ask, because it will check in the EEPROM of the microcontroller that is there any memory or stored code. If yes, it will ask for that certain code, and if not, it will, because it's already stored, it will ask for that particular code to be entered, what's already stored inside. And if there is no code stored inside, it will ask to add the code. Because I already done enter the passcode, so I have designed my code in such a way that we are 3 users, so I have 3 passcodes: 1111 for first user, 2222 for second user, and 3333 for the third user. So we can see if I enter 1111, so sorry, 1111, so it turns on the LED, and we will see the door should be open for 1 minute. It can go 60 seconds or 62 or 63 seconds, because this is somehow there is a little bit error in the Proteus, because I did spoke to Nick about it, and he said that should be fine if it's 62 or close to 60, 659, or sometimes it has some little bit errors with the clock signals, which is because it's still a virtual software, but it should be giving to 1 minute. So we will be seeing it for 1 minute. So we can see it will turn on for 1 minute and then it will turn off. In a similar way, if I will enter a wrong passcode, it will take the same time, because I'm using the one same delay system inside. If the passcodes matched, turn on the system for 1 minute, and if it does not match, turn off the system with the same delay. So we will be having the same delay of on and off time. So let's see, for that one should be 60, 62 sometimes. So 60, 61, 62 should be stopped at 63. So we can see it's on for 1 minute. Now if I will add the wrong code, because this I'm echoing the characters, so just to show what character I am showing, I will just echo the characters. So let's see if I'm using 555. So you can see it's a wrong LED, wrong passcode I've entered. So you have entered the wrong passcode, so the system will remain off for 1 minute, and then it will ask again for the code. I am not I'm echoing the whole array of the characters, so that's why we are seeing 5555 and it's showing the 555 stars at the output. Therefore, just for the simulation, because I will not use the echo when I'm building the hardware. So let's wait for that, because I want to show the passcode, the digit I am entering. So just for that, because in the beginning one, in the initial section, I just shows the stars, which shows I'm entering the right code, but I just want to demonstrate what characters I'm adding. So which I hope you will be considering. So let's wait for 1 minute, and after 1 minute it will show again enter the passcode, which I will enter the passcode, and you will see what characters I'm adding, and you will be seeing the echoes of those characters in the later, which actually just to show that I'm entering what characters I'm adding. So let's see, I'm adding 2222. So you see it's on. So first the first user, and the second user, and the third user will enter 1111, 2222, and 333 respectively. So if I will just not use echo, the next time I will enter the passcodes will be just the stars, the echoes of the characters. So that is my project, which is working perfectly, which still will have few improvement factors, which definitely every project has a gap of improvement, which I believe if I want to make an improvements in that, I would be considering, rather than using the Bluetooth device, which is good, we can add a a numerical keypad and an LCD that interface them, and we can add those characters, we can observe them on LCD, and the system will allow like a normal systems, but yet we can still use these Bluetooth devices, which is highly like very useful. So we can see now it should be stopped by now. So see, so now before was 64 seconds, the 63 seconds plus 63 seconds will give us 1 minute and 27 seconds. So now if I add like same characters, which is 2222, so we just see the echoes of those characters. So my code is working very nice and very good. So that was my whole project, and I have also provided the video for designing the PCB, which is already provided in my report. And I hope these things clear what I'm trying to say, or what I'm trying to do, or what I have built. So thank you very much for considering and watching my video. I have learned a lot of things. One more thing that I would like to clarify, in the hardware build, I had a problem with my Bluetooth device, so I have used UART communication through the serial communication board from UART to USB board, which I did spoke to Nick and Sarah about that, and I have provided the evidence which shows that the Bluetooth device was broken and was not working, but the code was working perfectly, which I have proved by using the hyperterminal and the UART to USB port communication. Thank you very much, and take care of yourself.